Well, hello, wonderful students. Welcome to Quiz 307 Help video. I owe you 306, so this will come out and then go back to 306. But I wanted to highlight this. This is a good initial trend. If you ever are in the yellow and the red, don't worry. You have multiple attempts, but if you don't want to do all attempts, just reach out, check this video, think about what we did right, what we did wrong, and the why. And that's all that really matters, okay? All right, so this one is due today. And it's combining functions. So here we're going to really kind of pull in some of our prior knowledge of adding, subtracting, multiplying, and dividing, but polynomials, not just regular numbers. So we'll talk about it each step of the way. This might be a little bit longer as I try to review some concepts and vocabulary words with you. So feel free to skip to what you need. But remember, the steps that we are following is a great skill to practice. It's a great skill to practice because a lot of things in life will be taught to you from like a manual or a video or this or that, and you're going to follow along and piece in what you want. Okay? All right. There we go. It wasn't zooming in. F of x equals 2x squared plus 3x, and g of x equals 5x squared minus 2x minus 6. That's function notation. That's how you read that mathematically. What is f plus g of x? Now that's combining function notation, and it's exactly as you would think if this is what you think. If it's not what you think, then it's not what you think. All right. This notation from notes, from class, from your book, is the same thing as just f of x plus g of x. Now, I had some great thoughts on how to think of this, how to remind yourself about it, and it made me really think about what is happening here. One of the things I want to highlight is that function notation is slightly different than the notation we would see with multiplication. Sometimes when we first would have seen parentheses and variables, we would have read this as f times x. That's not what's happening with function notation. Just like it's not f plus g times x, if it helps you remember in a different way, that's fine. Like however, whatever you want to use to help you remember something, it's fantastic. But just differentiate between what the notation is saying in this context. That can be really hard when you get into technical information, but you can do it. Okay, so now we just know it's f of x plus g of x. What does that mean? Hopefully you're like, well, that's just going to be 2x squared plus 3 of x plus 5x squared minus 2x minus 6. That's it. You're just going to rewrite that there. Once we do that, I'm actually going to write, I'll write it down here. 2x squared plus, don't worry about this. Ignore that. 3x plus 5x squared minus 2x minus 6. Just made it, just fit. Let's get that out of there. Now we're basically done. We just need that final step of combining like terms. Now, I watched this wonderful video about treating math as a language, which of course it's a language. It's the language we use to write about the world around us and qualify it, quantify it, and think about it. So if we have 2x squared plus 3x plus 5x squared minus 2x minus 6, and we're looking for this concept of like terms, let's focus on the sounds and the words we're making and just think about it, okay? The way we talk about combining like terms is you combine the coefficients of terms that have matching variables. And the matching variables need to have the same letter and the same exponent. And then you just add or subtract their coefficients. So there's a lot of vocabulary in there. Again, coefficients are just the numbers in front of the variables, and the variables are just the letters. And then the exponents are the little number that tell you how many times that variable is being multiplied by itself. Think about it. Google that stuff if you, or no more free advertising. Search what is an exponent, how do they work in variables, or combine like term videos. Look up combine like term videos if you need some more support. 2x squared plus 5x squared. Well, if you have 2x squared plus 5x squared, it's like you have 2 apples plus 5 apples, so it's 7 apples. but instead of 7 apples, it's 7x squared. Does that make sense? I have to find that video. 7x squared. Okay. Next, those are the like terms because 2x squared plus 3x, ooh, you can hear it. X squared, x squared, x. You can't add those. They're not the same. Apples and oranges. But if you have 3x minus 2x, so if I have 3x and I take away 2x, I'm left with 1x. There's an invisible 1. And then we have minus 6. Oh, minus 6. There's nothing else over there. We're done. Minus 6. So if you have this variation, here's your answer. But if you don't have this variation, the same strategy can be used to find yours. You're basically just going to take a look at the functions you have, and you're going to add them, looking for like terms. Add the like terms, just by itself. It just comes along for the ride. It has to come with you. You can't just get rid of it just because it doesn't have a partner. It just comes right along. Okay? Think about it. Coefficients, combining like terms. How do we do that? Boop. Okay. And remember, in the class recording, go back, check the class recording. We do more practice problems. George! All right. So let's make up a story for George. I like to think George has opened a new store and he's monitoring its success closely, that he is a dog groomer, but not just any dog groomer, the fancy kind that makes your animals look like other animals or objects, like cotton candy or a leopard or a lion. I don't know. So he grooms your dog, dyes your dog's hair, and he's doing wonderful. Go, George. He has found that his store's revenue He has found that his store's revenue each month can be modeled by R of x, the revenue function, is equal to x squared plus 5x plus 14, where x represents the number of months since the store has been open, and since the store opens the doors, and Rx is measured in hundreds of dollars. Key things that will help you. Let's pay attention to key ideas in this story. So we have months open, we have hundreds of dollars. He's also found that his expenses each month can be modeled by a cost function, or C of x, equal to x squared minus 3x plus 4, where x represents the number of months that the store has been open, and C of x is measured in hundreds of dollars. Okay, that's helpful. So x represents months since the store has opened the doors. The output, units, hundreds of dollars. Just keep that in mind. All right, let's see. Now, they're asking you, what does R minus C of 3 mean about George's new store? Okay, well, let's just go to what we've learned. And again, we would have had this in our notes or from our book. R minus C of x is the same thing as R of x minus C of x. So now with this new bit of information, with the 3 being there, we would just replace the 3 here and the 3 here. So that would become R of 3 minus C of 3. Well, cool. That's a nice trick. This is nicer because it's going to give us all numbers and we're going to get rid of variables. So let's use this strategy. I think it's important to be able to apply this strategy because now we can actually just use a calculator and directly type it in there, which I will show you in this video. We just need to keep reading it correctly. R of 3 minus C of 3. Well, this is R. So if we plug in a 3 here, we've got to plug in a 3 there and a 3 there. We have to substitute in, replace every x with the number 3. So we have x squared, that becomes 3 squared. Plus 5 times x, well, that becomes 5 times 3. Plus 14, no x, so it just stays. That's our R of 3. Minus, we do need parentheses here. C of 3, well, that's C of x. We just plug in 3 wherever we see x. X squared becomes 3 squared minus 3 times 3, because 3 times x, plus 4. Boom. Now, if we were doing this with variables, we would need to distribute. We'd need to distribute the negative to each term because we're subtracting each term. You'd have to distribute that and subtract to subtract correctly. Okay, so caution, it's not the same as addition. Addition has the associative property. So the first problem, we could just add. It was no big deal. We could just combine like terms, whatever their signs were, their signs were. If it was minus, it was minus. If it was plus, it was plus, because addition has the associative property, which means grouping doesn't matter. We can regroup, rearrange, and it will still be equivalent. For subtraction, that's not true. You need to distribute across parentheses and subtract or change the sign of each term in those parentheses. Okay? All right, but don't worry, because once we use this skill, we can just bust out our calculator and we can type that whole thing in there. Okay, parenthesis. I'm still going to use parentheses. Hey, parenthesis, 3 squared, arrow over, plus 5 times 3, plus 14, close parenthesis, minus, and we need this parenthesis, 3 squared, arrow over, because I don't want to minus 3 times 3. I don't want to write it in the exponent, plus 4. Notice 3 squared is the same thing as 3 times 3. So 3 squared minus 3 times 3 is just 0. But okay, anyway, plus 4, close parenthesis, 34. So by using the method where we substitute in the value that they gave us, we can just type the whole thing into the calculator and let it do the work for us. That's a good thing. We want to use our directions, follow it, and then let it go, right? If it says turn the mixer on for 5 to 10 minutes, turn the mixer on for 5 to 10 minutes. It says check for this type of consistency. All you got to do is watch the mixer for that type of consistency. You're good to go, okay? All right, here we go. 34. That's our answer. What does it mean? Well, that's what they're asking us. What does it mean? 34 is the output. 34 is measured in hundreds of dollars. So $3,400. 3 is months, 3 months. If you have money coming in, revenue, and you take away the money going out, that, my friend, is your profit or loss. If you're negative, it's a loss. But if hopefully for a new business, it's your profit. So then if we get 34 as the final, when we have our revenue minus our cost in hundreds of dollars, it's $3,400 after 3 months, because that's our X of business. That's what you're looking for? Cool. A couple of things that will help you. Say you did the math right and you get 34. And then you're like, okay, 3,400. Well, here's the only one with a 34. This is a 24. So it's either $3,400 or 3,400 items. So those two key details alone can help you decide. And they tell you right here, hundreds of dollars, $3,400. Okay. Third month of business, third month of business, third month of business, third month of business. So that one wouldn't help you pick between the answers, but that key detail would. Okay. Use it. Test-taking strategies are important. They're not going away, for better or for worse. They will be used in your life for certifications, to pass things, sometimes to even get interviewed. You'll have to take a test. So practice now. And then if you're not great at test taking, tell your future, like, hey, I'm not great at this, but I would be great at this job. So don't give up just because you score low on a test or ever fail a test. No, because the test isn't the real work that you're going to be doing. It's just kind of a little gatekeeper, a little stepping stone. You should still study and try your best, but don't let it stop you. If you're bad at taking the test, go tell somebody and then show them what you're good at. Question 3, variation 2. FGX. What? This says f times g of x. That's combining function notation, and it's exactly what you think. It is f of x times g of x. Well, here's f of x, here's g of x. I'm going to write it up here. 4x squared minus 5 times x plus 3. That's it. That's f of x times g of x. We're going to use FOIL. So you can use anything you like. You can even go use Symbolab. You can use your fancy calculators nowadays can sometimes just do this for you. But FOIL is a common mnemonic device to help us organize the distributive property. Remember, whenever we're multiplying polynomials, the key idea is that we want each term to be multiplied to each term in the other parenthesis. That means we want the 4x squared to be multiplied to the x and the 3, and we want the negative 5 to be multiplied to the x and the 3. So FOIL just helps us do that, but however you organize it is perfect. FOIL stands for first, so that's your first term, 4x squared times x. That will be 4x cubed. X times x squared, times x, that's x to the power of 3. O stands for outer, so you look at the outer parentheses, 4x squared times 3. So 4x squared times 3. 4 times 3 is 12. There is no other x, so it just comes along for the ride. It's now 12x squared. That's what we talk about when we're dealing with coefficients. When you're multiplying, the coefficients multiply together. There's 4 times 3, that's 12. Over here, there's 4 times an invisible 1, that's 4. Then you multiply the variables, x squared times x. Well, x squared is 2x's, x times x, and then another x is x cubed. That's where that little exponent's coming from. If there's no exponent or variable over here, it just comes along for the ride. The inner terms, that's minus 5 times x. Minus 5 times x. Boom, that's exactly it, negative 5 times x. Minus 5 and negative 5 are very similar. They just kind of change depending on if negative 5 is just we're describing the term. Minus 5 is we're describing what's going to happen. Like we're going to take away 5. We're going to minus 5, subtract 5. Negative 5 is like it's negative 5. The same thing happens when we start to combine it with other numbers. Anyway, just pay attention to negatives, that symbol. And finally, we have last. That just means exactly what it sounds like. We have this negative 5 times this positive 3. We get negative 15. Final step, check for like terms. We got ourselves an 4x cubed. Nope. 12x squared. Nope. Negative 5x. Nope. And a negative 15, the constant. Okay. Cool. So for question 3, it's combining functions using multiplication. You're multiplying polynomials. Remember, we talked about this way back in Unit 1. Trust those skills. These are very common, repetitive algebra skills that they are hoping, by they, I mean the math curriculum writers, are hoping that you are fluent at. If you're not fluent, figure out what's causing the hiccup, like what confuses you when you get to there, when you're following the instructions, you're like, all right, what is different about your variation versus my variation in multiplying either the variables or the coefficients, okay? All right, think about it. That's the best thing. Whatever grade you get doesn't really matter as long as you're still thinking about it, because in your mind, you're growing. All right, variation 3 of question 4. Here we go. This f over g of x, f divided by g of x, is exactly the same thing as f of x divided by g of x. Caution here, just really quickly. G of x is now a polynomial on the bottom of a fraction. That means division by 0 is possible. So we need to pay attention that g of x cannot equal 0. That's just a common thing. We always have to be aware if ever we have a letter, a variable, on the bottom of some sort of ratio, rational, denominator, fraction, whatever, the denominator, if it has at all a potential of equaling 0, we have a problem. We need to be aware of it because division by 0 is not possible. It's not defined. It's not definable in most circumstances. Okay, let's plug this stuff in. Here's f of x. I'm going to write it up here. 4x squared plus 19x minus 5. Boop. All over 4x squared minus x. We're going to start with a common misconception. I'm going to zoom out. I'm going to get red. Okay, no, I'm not. I'm going to get red as I can. And then we'll undo it. 4x squared over 4x squared. We might want to cancel them. We might want to be like, oh yeah, they match on the top and the bottom. Goodbye. We can't. We cannot do that because they are not factors. It needs to be multiplied in the top and multiplied in the bottom before they will cancel out or divide out and equal 1. Division is the opposite of multiplication, but look, this one's being subtracted or something's being subtracted from it, so it's not being multiplied. And look, up here, this 4x squared is being added to the 19x minus 5. So they may look exactly similar, but we gotta stop. That's not quite right. So when we see this, not quite right, we actually want to go ahead and factor. That's going to be what we need to do. Now, I showed class SemB Lab and other students shared PhotoMath, and the reason those two resources are better than some of the other ones out there is because they break down the steps, which remember should be your goal. Following steps, checking the steps, because math class is a safe place to see if you can replicate those type of algorithms or steps to follow to get to the right answer. And no big deal if you don't. Check it, see what's the hiccup, what's hooking you up. What's the Anyway, so we want to factor. That's the strategy. We're going to start with the denominator because it's easier. And we'll use what we're going to review right here when we factor the numerator. 4x squared minus x. I start to think for greatest common factor comes to mind, common factors come to mind, and I think to myself, do they have anything in common, either the number part or the variable part? 4x squared, well, let's just write it out. That's 4 times x minus x. Well, okay, they both have x's. So let's factor that out. This is how I factor it out. I pull out what I want to take out. I'm going to take out an x. I'm going to take out an x, right? So there it is. Parentheses, now I need to think what's left. If I take out an x over here, minus 1. And if we remove that in order, right, negative 1 times x is negative x. Or if I take out an x, there's an invisible 1 there. So what's left is just that negative 1. Over here, if I take out this x, what's left? Well, 4x. And that one should be pretty straightforward because x squared means x times x. Moving to the top. We'll stay blue. No, we'll change it. Let's go purplish. Boop. 4x squared plus 19x minus 5. There's a little bit more steps. And again, you're welcome to use technology to help remind you, how do I factor this? What do I do? Well, 4x squared plus 19x minus 5 is a quadratic expression, and we have some factoring strategies that we can use. This one doesn't have a leading coefficient of 1, so we need to do an extra step. Well, what we're going to do is we're going to take that 4, and we're going to take that minus 5, and we're going to multiply them. You might have different numbers. Multiply them. That equals negative 20. Next, we're going to split this into potential factors, right? Like 1 times negative 20, or 2 times negative 10, or 4 times negative 5, and that's it. Okay? Out of these potential factors, we need to look at which ones will add to positive 19. Okay. So now I have a pretty good idea. 4 and 5 will never get to 19. 2 and 10 will never get to 19. So I'm going to go up here with this 1 and 20, but I'm going to switch it. 1 times negative 20 works, but it will add to negative 19. So I'm going to make it negative 1 and positive 20. Negative 1 and positive 20. That's what I'm going to use. Use how? When we have a leading coefficient that isn't 1, we need to factor by grouping. But in order to figure out which groups to factor or to split it into, we need this step, so we can now rearrange this plus 19x to this 4x squared. So sorry, x squared's got to come with you. Plus 20 group, plus 20x group plus negative 1, I'm going to write the 1, even though it would be invisible, negative 1x minus 5. All right, so what just happened? This is the key thing that just happened. We just rewrote 4x squared plus 19x minus 5, but we split this 20x plus negative 1x or 20x minus x gives you that 19x. And we just split it like that. It's still equivalent. It's an equivalent expression, so we can factor by grouping. We chose it. We purposely did this. Okay? Now we look for exactly what we did on the bottom, common factors to factor them out. This one has a number part and a variable part. 4 is a factor of 20, so I can pull that out. There's an x and an x, so I'm going to pull out a 4x. What's left? 4x squared, if I take out a 4x, I'm just left with an x. Why? Because 4x times x is 4x squared. If I have a plus 20x and I take out a 4x, well, I'm left with just a 5. Why? 4x times 5 is 4 times 5, which is 20, times x, which is 20x. And then over here, I'm just going to take out a minus. I'm just taking out a minus, so I'll be like x plus 5. What? Yeah, I took out this negative 1 and this negative out because it's like a -1 times a +5. Ooh, think about that. Thoughts? I'm just factoring out the negative because if I redistribute it through, I'd get -x and -5. Think about it. Ask questions. All right, now we're almost done. We now final step. Look, there's an x plus 5 and an x plus 5. Yep, you can still factor that out because that's 4x times x plus 5, and there's a -1, that invisible -1, which I just put it there, times an x plus 5. And then what's left? You're left with a 4x, so parenthesis 4x, and you're left with a -1. Cool. We're one step from being done, and that's where we get to cancel that common factor in the numerator and the denominator. So in this case, with polynomials, you need them to be multiplied. So you're looking for those parentheses or some sort of multiplication. So you need that multiplication in the top and the multiplication in the bottom. You find the ones that are matching. So hopefully you saw this 4x minus 1, 4x minus 1, and you're left with x plus 5 over x in this variation. Boop. Okay, so now some questions arose, like how do I know what my domain restrictions are? Well, just pay attention to your answer options. They are all unique. So as long as you do your math correct, you will have only one option to choose, and they will just give you your domain restrictions. Those are the values of x, 0, and 1/4, where the denominator, g, where this whole thing equals 0, and you can check it for yourself. It won't help you solve because, yeah, they have similar domain restrictions. And notice that's the common misconception if you just cancel out those two. Oh, the sneaky sneaks. So, yeah, it's not those two. Anyway, keep thinking about it. We're almost done. Almost done. I know this is a little bit longer of a video, but we got it. Fraction, no. It is like a fraction, function fractions or divisions of polynomials. You need to kind of factor to try to simplify, but again, you're welcome to use technology to help you with those skills. All right, we have a horse-drawn carriage tour company, oh my, has found that the number of people that take their tour depends on the price charged per customer. The more the company charges for a tour, the fewer people decide to take the tour. Yes, it's one of the hardest things that businesses have to decide is their price point. So it's a very good observation, and it's another reason why math will help you at whatever you pursue. The function c of x, 50 plus 5x, represents the price charged per customer. Okay, so that's their cost, but it's their charge, I guess would be a better word, for riding in their carriage. Okay, but x is the number of $5 increments that they charge over a rate of $50 per person. So they've noticed that 50 is a good base rate, and if they try to hike up the prices, they get fewer people and so forth. So then they've noticed that their profit function, P of x, is equal to $100 minus 2 of x will be the number of customers, or maybe P is people. I don't know. Anyway, represents the number of customers expected for the day. Yeah. Where x is the number of $5 increases they charge over a rate of $50. Does that kind of make sense? I know it's kind of confusing. Anyway, what does P times C of 2 mean about the horse-drawn carriage company? So let's solve the math part, and we'll think about what does it mean in the terms of our story problem. So we know that this 2 represents the number of $5 increases. So they've increased it 2 times, or $10. Okay. And we know that the people who ride it times the amount they're charging is going to be how much they make that day, right? The number of people who ride times how much they charge will be how much money they make that day, not subtracting cost, right? They need to subtract their costs, like employees, horse food, I don't know. Okay. But let's use some math and we'll think about the rest of it. P times C of 2. That's the same thing as P of 2 times C of 2. All right, let's do it. Well, P of 2 is just going to be this, where I replace 2 wherever I see x, minus 2 times 2. Cool. And the charge is just C of 2 is going to be that 50 plus 5 times 2, where I replace 2 wherever I see x. Beautiful. That will become 4, so that will become 96 times 50 plus 10 is 60 times 60. Okay, we have a calculator. Boop, 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 boop. It's a calculator. It's thousands of dollars. No, I didn't click anything. I don't know why you auto-click. Well, good job. More of you have taken it. More of you have done well. Okay, so we had that 96 times 60. 96 times 60, which is 5,760. So let's go take a look. All right. So now you have only two options, so be careful. 5,760, 5,760. Look, every other word is exactly the same. So you'll have two. Okay, so this is the key difference, $60 versus $40. And you can figure that out by plugging in that 2 for the charge function. You have 50 plus 5 times 2. 50 plus 10 is $60. So that's how much they can expect to take in that day if they're charging $60. All right, you guys, keep doing the thinking. Let me know if you have any questions. Love questions. Good work, and I'll see you later.